Let's take a look at this problem here. It says the position function of an object is given by RT, equaling t squared 5t, t squared minus 16t. And it says at what time is the speed a minimum? So what we're going to do here is we have to understand what the formula for speed is. And the formula for speed is the magnitude of the velocity. So let me write that out. So we have the magnitude of the velocity. That's what speed is. And another way I can write this magnitude of the velocity is this is also equal to r prime t, the magnitude of the r prime t. And that all equals speed. Okay, so that's what we're going to need here first. We need this speed function to talk about the minimum. So given our RT here, we're going to take the derivative first because that's what's going to give us our velocity. And we'll go from there. So then r prime t is equal to 2t, comma 5, comma 2t minus 16. And for all of those, since they're just polynomials, it's very quick, just a simple power rule. And honestly, I bet you most of you can do it in your head. So it's great. So now what we need is we need the magnitude of the r prime t, and that's what's going to give us our speed. So we can say this implies the magnitude of r prime t here, and that's going to equal just the square of each of these summed together and then square rooted. Okay, so that's what we're going to do now. So this, and I'll just write it out. I like to skip this step, but just in case you're having a little bit of issues with the magnitude, here it is. And like I said, try to remember these not these formulas, but these computations here. All right, plus, and now this is where it gets fun, 2t minus 16 squared. And then it's all the square root of. Okay, now we're just going to simplify this thing the best we can. So this is going to be just 4. That's a simple one. Most of you guys would have gotten that pretty easily. 4t to squared, yep. Plus 25, and then this one here is the one that's a little annoying on the end here because this is a binomial here. Don't write 4t squared plus 64 minus 64. It's not what it is, so be careful with that. This is a FOIL here. This is really 2t minus 16 times 2t minus 16, and that's what it really is there, so be careful with those. A lot of people mess those up at all levels. So anyways, this is going to turn out to be 4t squared plus, or I should say minus, 64t, and then the last thing is going to be plus 256. And then again, remember, it's all square rooted. Now we're going to simplify this as much as we can. We definitely want to before we start trying to minimize this thing. It's better to clear it up as much as you can. So then this equals square root, and we're going to put my t squareds together. So that's 8t squared. And then minus 64t, and then plus 281, all square rooted. And that's because I'm putting everything together that I can. So those two I can put together. It gives me the 281. And then 64 I just brought down. There's nothing else to add to t. Okay, so that's what we end up with. So now we have to minimize this. So now taking a derivative of the speed function, we'll find the minimum. So let's just do that. So when I look at this, I want to think of it as 8t squared minus 64t plus 281 to the 1/2 power. Because then I just have a chain rule here with a power rule with a chain. Power rule with a chain of another power rule. Okay, so anyways, that's going to give us, and I'll just call it, I'm just being creative, I'll call it the speed. Speed, and I'm going to say the derivative of this. And that's going to be the derivative of all of this And we're going to have that power rule first. So we're going to bring that down so I get a 1/2 here. And then it's everything on the inside still. So 8t squared minus 64t plus 28 to the negative 1/2 power. And then I have to times that by, because it's a chain here, and that's going to be 16t because we got to take derivative of the inside now. Just going through this just in case you haven't done it in a long time. So minus 16, and that's our derivative of this thing. So I'm going to write this in a simpler way so you can actually see what's really going on here. Because it's not too bad. It just looks horrible right now. So this 1/2 times, oops, this shouldn't have been 16 here. I got to fix that. I'm glad I caught that. That should have been 64. And it comes from here. All right. Hope I didn't upset you too much there. So anyway, so I'm going to take that 1/2 and multiply it through to this thing here, just to make it a little easier. And that's going to make it 8t minus 32. So on the top of this thing, I get 8t minus 32 all over. And on the bottom, I'm going to get square root of 8t squared minus 64t plus 281. Forgot my 1 there also. So there it is. I fixed it. Okay, so that's what I have on the bottom. So this is our derivative here. So now I have to find out where my derivative is 0 to find a max or a min. But the only thing I really have to worry about with this is the top being 0, because that's where this whole thing is going to equal 0. Well, I should say the whole thing is going to equal 0. So if the top is 0, the whole thing's 0. And the bottom won't interfere with that. If the top is 0, the bottom won't be 0. So we're good with that. But that's what we have to find now to find a maximum or a minimum. So now what we're going to do is we're just going to say 8t minus 32 equals 0. And we move over the 32, divide by 8, so t equals 4. So there's our answer. Now we don't know if it's a minimum or maximum. We just know that's the optimal t value, whatever that means. So to find if it's a max or min, we can use the second derivative test. That means I take the derivative of this here, the 8t minus 32, and then I just plug in t equals 4. And if it's positive, then it's concave up. And if it's negative, it's concave down. And if it's concave up, that means it's a minimum, right? Because you think of concave up, and it would be down here. So that would be a minimum. And if it was concave down, it would be this way, which tells me this point right here would be a maximum. So that's the idea now. So one more step here. Now this derivative is going to be more difficult. I don't know that I like this problem anymore. Oops. Because I'm taking the derivative of the 8t. And this is going to be a quotient rule. So on the top, it's going to be 8 times the bottom, right? Derivative of the top times the bottom. So 8t squared minus 64t plus 281 minus the derivative of the bottom, which the derivative of the bottom is this here. Think about where that came from. That was just the square root of. That's a little nasty. Okay, so that's going to be that 8t thing. All I did was cut and paste it since it was there already. And that's going to be over the bottom squared. So that's just going to be the 8t squared minus 64t plus 281. Because the square of a square root, the square root goes away. So this is really what we have here. And then what we're going to do is we're just going to plug in 4 for t. And that's going to take a minute. I did miss one part of this. When I took the derivative of the bottom here, so I'm supposed to do derivative of the bottom times the top. And that's what I minus here. So I just took the derivative of the bottom. I also have to times it by 8 t minus 32. So I did forget something there, so be careful with that, guys. Easy to mess up. Now when I plug in 4 here, the nice thing about it is this whole piece right here goes to 0, because when I plug in a t here, a 4 there, 4 times 8 is 32. 32 minus 32 is 0. So actually, this piece right here all zeroes out. So it's not too bad. It looks really bad though. The answer, and I'll just write that out for you, where t equals 4, that derivative, or second derivative I should say, would be, and I'll call it the speed second derivative. That would actually be 8 square root of 17 over 51, which is greater than 0. Which tells me it's open upward, which tells me then that t equals 4 is going to be a minimum. So this implies t equals 4 is a minimum by second derivative test. There it is. Okay, so there's all the information I need for this problem.